Okay, welcome back to section 2.2. We're going to be talking about graphing and sketching the graphs of these polynomial functions. So what we're going to do is we're going to start by finding the zeros. Actually, we can do the leading coefficient first. N is 4, it's even, and the leading coefficient is positive. So the graph should have potentially 3 turning points, and it should look like this, where it rises to the left and rises to the right. So now, looking at our zeros, 0 equals x to the 4th minus 3x cubed. So 0 equals, so what we can do is we can factor out an x cubed. X cubed times x minus 3. It's fully factored, so now what we do is we set each factor equals 0. X cubed equals 0. X minus 3 equals 0. Take the cube root of both sides. X equals 0, and x equals 3. So there's our 2 zeros. Now, the first 0 is repeated 3 times. It has a multiplicity of 3. So with that odd multiplicity, it's going to go through that point. So there's our 2 x-intercepts. Now, we want to find some additional points to be able to graph what this will look like. So here's where the calculator comes in handy. Use the graphing calculus in the table function. -2, -1, 0, 1, 2, 3, 4. Once you type it in, getting the values is easy. You can find as many as you want to. So when x is -2, y is 40. Then we're at -1, 4, 0, 0, 1, -2, 2, -8, 3, 0, and 4, 64. So -240 is off the graph. So we're at -1, 4, 0, 0, 1, -2, 2, -8, and then we're all the way back up. So what happens is it's going to go down through 0, 0, keep going down, and then bounce back up again. So that's the graph, basically what it's going to look like. So there is our graph. So remember that end behavior, it rises to the left and it rises to the right. Now, problem number 11. So once again, the degree. The degree n is 3. That's odd. Our leading coefficient is a +2, so it's positive. So our shape, because it's odd with a leading coefficient that's positive, it's going to look like that. So it's going to have at most 2 turning points. So now we'll find our zeros. 0 equals 2x cubed minus 6x squared plus 9 halves x. So now what we're going to do is we're going to get rid of the fraction by multiplying every term by 2, just to make it a little bit easier to work with. So we get 0 equals 4x cubed minus 6x, I'm sorry, that's 4x to the 4th. What am I doing here? That's right. 4x cubed minus 6x squared plus 9x. So we can factor out the common factor of x. So it's going to be 4x squared minus 6x plus 9. And now we can, did I say 6x? It's a 12x. Sorry about that. Now we can factor this. And when you factor 4x squared minus 12x plus 9, you get 2x minus 3 and 2x minus 3. So it's 0 equals x, and it's going to be 2x minus 3 squared. Now, x equals 0, and 2x minus 3 equals 0. So x equals 3 halves. Do you see that binomial being squared? That means it's repeated twice. And that has a meaning to it. So we have our intercepts at 0 and 3 halves, which is 1.5. Now what it's going to happen is it's going to go through 0, but it's only going to bounce at the 3/2. So once again, we'll graph this. So we have -2, -1, 0, 1, 2, 3. So -49, -12.5, 0, 0, 0, 1.5, 2, 13.5, and 3, 50. So -2, -49, way off the graph. Then we're getting a little bit closer to the graph. Then we're at 1 and we're at 0.5. And then we're at 13.5 for 2. So it's way off the graph. So what's going to happen? It's going to go up, go through 0, 0, back down, and it's going to bounce. It just touches that x-axis. It doesn't go through the x-axis. So there's what I mean when it has that multiplicity that's even. It bounces off of the graph. It doesn't go through the graph. So you can see our end behavior. It falls to the left, and it rises to the right. And we found all of our zeros as well. So number 12, same thing. Our degree, n, is 3, which is odd. And our leading coefficient is a -2, so it's negative. So the shape of it, because the leading coefficient is negative and the degree is odd, it's going to look like this, where it's going to rise to the left this time and fall to the right. So now when we find our zeros, 0 equals 2x cubed plus 6x squared. 0 equals, so we can factor out it's a negative 2x squared. If we have a negative leading coefficient, we always factor out the negative. So that leaves us with x minus 3. So now set each factor equal to 0, -2x squared equals 0, and x minus 3 equals 0. So you divide by -2, you get x squared equals 0. Take the square root, x equals 0, and then x equals 3. Now, because that x was being squared, that 0 is repeated twice. It's got a multiplicity of 2, whereas the x equals 3 has a multiplicity of 1. So 0, 0, it's not going to go through that x-axis there. It's just going to touch the x-axis there. And we have another x-intercept at 3. So now we can make a table. -2, -1, 0, 1, 2, 3, 4. Remember, the calculator is doing all the hard work for us. So we have 40, 8, 0, 4, 8, 0, and -32. So we're at -1, 8. Up here, 0, 0, 1, 4, 2, 8, and then -32. So it's going to go down, bounce at 0, 0, back up again, turn, and go back down through that 3. So there's our graph. You can see at that repeated 0, the one that's repeated twice, it goes through. If it was repeated 3 times like it was in the previous problem, it goes through. Even multiplicity, it bounces. Odd multiplicity, it goes through. So now we can see our end behavior. It's going to rise to the left and fall to the right. Let's do one more graph. So the degree, n, is 4. That's even. Leading coefficient is positive. So it's going to have up to 3 turning points, and it's going to rise left and rise right. That's the basic shape of the graph. So we're going to find the zeros now. 0 equals x to the 4th minus 4x squared. X squared times x squared minus 4. X squared, and then when we factor that, we get x plus 2, x minus 2. x squared equals 0, x plus 2 equals 0, x minus 2 equals 0. So we take the square root of both sides, we get x equals 0, x equals negative 2, and x equals positive 2. Now, because of that x squared, that's repeated twice. It's got an even multiplicity. So there we have all of our zeros. So keep in mind at 0, 0, it's going to bounce. It's not going to go through. It will go through negative 2, and it will go through positive 2. So we can make a table using the calculator. That's going to do all the hard work for us. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Negative 3, we're at 45. And then we're at 0, negative 1, negative 3, 0, 0, 1, negative 3, 2, 0, and 3, 45. So 345 is way off the graph, and so is negative 345. So then we're at 1, negative 3, negative 1, negative 3, 0, 0, 1, negative 3. So we're going to be going down, through, bounce back, or go back up, bounce at 0, 0, down, and back up again through positive 2. You can see that even multiplicity in play again. So this one, for the end behavior, it rises left and rises right. And that is graphing of these polynomial functions. The important thing to know is how to find the zeros, what the end behavior would look like, and what happens with even multiplicity and odd multiplicity. I'll be back again with another video to finish up this section. Thank you and have a nice day.